Quick, graph y equals the sign of the quantity x minus 2 pi over 3 by hand 2 different ways. This is part of the family of functions series. You will need paper and straight edge, and we suggest you create grids similar to the ones at the right as needed, and press pause as needed anytime during this video. First way is with the sign dance. Recall the graph of y equals sine of x. This is one period or wave of the sine function. Note the 5 key points of interest. These key points are affected by the parameters in the equation, as all points are, and the only parameter we have is a minus 2 pi over 3 inside the parentheses, which shifts each point horizontally to the right 2 pi over 3 units. Only. That's the only change made. The initial point, which is normally at the origin, is shifted to the right to 2 pi over 3 comma 0. We're going to need to change the units along the x-axis. So we're going to mark off every pi over 3. Pause is needed. Now let's plot the point 2 pi over 3 comma 0. The end of the first period is normally at 2 pi 0, but we're shifting every point to the right 2 pi over 3, so this will be 2 2/3 or 8/3 pi comma 0, which is also one period away from the initial point, which is 2 pi away, just a way to double check. Halfway between the initial point and the end of the period is another point of inflection. That would happen here as well, and this is going to occur at 5 pi over 3 comma 0. Notice it's halfway between the beginning and ending of a period. Halfway between the first 2 points of inflection is a maximum, so halfway between will be a maximum at 1, and this will be at 7 pi over 6 comma 1. We could have marked this off in pi over 6 units as well. Halfway between the second and third points of inflection is a minimum, so that would happen about right here, and that would be at 13 pi over 6 comma negative 1. Pause is needed. Connect the points as a sine wave, so we have concave down, then concave up. This is one period of the sine wave. We need to duplicate the wave in the negative direction to the left. So we'll go back 2 pi, the period, from that point, back 2 pi from the max, back 2 pi from that next point of inflection, and then back 2 pi from the minimum. Again, connect the points as a sine wave, frown, then smile. Comparing this to the parent function in blue, each point is shifted to the right 2 pi over 3 units from the blue to the green graph. We show that here on a few of the points. We say that the green curve has a phase shift of 2 pi over 3 to the right, and that's a big deal. Pause is needed. Second way is with a table. So here we'll use the axes values, and we're going to ask you to pause to complete the table. These are the values that you should know. We need to create a second table, which we'll do in green here. We're going to need to add 2 pi over 3 to each of the x coordinates. That's the only thing we're going to have to do. So 0 plus 2 pi over 3 is 2 pi over 3. The y coordinates are going to stay the same, but it looks like we're going to need to change the unit markings along the x-axis. So every pi over 3 will be marked off along the x-axis. Pause is needed to make your grid. And now we plot 2 pi over 3 comma 0. Again, adding 2 pi over 3 to each x coordinate. Pi over 2 plus 2 pi over 3, we need to get a common denominator, which in this case is 6. So it's 3 6 plus 4 6 is 7 6 pi, comma 1, because the y coordinates stay the same. Pi plus 2/3 pi will be 5/3 pi, comma 0. 3 pi over 2 plus 2/3 pi, that would be 9/6 pi plus 4/6 pi is 13/6 pi. And that's going to be comma -1 because it's a minimum. And 2 pi plus 2/3 pi is 2 2/3 pi, which we usually write as 8 pi over 3, comma 0. Connect as a sine wave, concave down, concave up. And plot another period to the left. Again, going back 2 pi from each of the key points of interest. And connecting as a sine wave. This is phase shifted to the right 2 pi over 3 from the blue parent function. Now you try one. Graph y equals the sign of the quantity x minus 3 pi over 4. Use either method or both for the practice. Pause as needed and resume when you're finished. And you can see that this graph is phase shifted to the right 3 pi over 4 units because of this minus 3 pi over 4 inside the argument.